Hi, welcome to the notes for H4-7, Solving Polynomial Inequalities. Our objective today, students will solve polynomial inequalities and represent answers algebraically and graphically on a number line. For those of us that like procedures, I've listed out a couple steps here that you'll do on each of the problems. So number one, you're going to find boundary points by solving each inequality as an equation. After we do that there, you're going to take values and plug them in to identify the solution sets. Let's take a look here at the first ones. The directions here state find and graph the solution set to each inequality. We have here, it looks like k times the quantity of k minus 5 is greater than 0. So the first thing we're going to do here, just like it said there in those steps from the previous slide, we're going to take k times the quantity of k minus 5, and we're going to set it equal to 0. We're going to solve this like it's an equation first. So please don't distribute the k through, because if you distribute the k through here, you're not going to be solving it. You're going the wrong direction. That would have been k squared minus 5k equals 0. Okay, we don't need to go that way because then we would have to factor it. So it's already factored that k was the greatest common factor, so we'll set each factor equal to 0 and use the zero product property here to get our answers. So what these answers end up being are 0 and 5, and these are our boundary points. If you remember from the past couple lessons here, we talked about boundary points. Those are on our number line where our rays will come out there to represent all of our answers. So our boundary points here, 0 and 5, we'll put them on the number line. And since this is just greater than, we're going to go ahead and just put an open circle at each of those boundary points. Our job now is to figure out where the solution regions will be. Remember, if it's like a conjunction here, our solution set will be between the boundary points. If it's like a disjunction here, it will be outside the boundary points. Okay, now, polynomial inequalities, will sometimes follow those little tricks and things that we've been doing, but it may not always work here. So what I'm going to ask you to do here is to choose values from each of the regions and plug them in to see which ones make it true. You'll see here I put -1, 3, and 6. So we'll start here with -1. If k equals -1, we're going to plug it back into the original inequality here. -1 times -1 minus 5 should be greater than 0. So -1 times a -6 is going to give us 6, which makes that a true statement. That means that -1 is part of the solution set, and so are all of the rest of the values here that are less than 0. So everything this direction is a solution. Well, if those are solutions, chances are everything over here greater than 5 will be. So let's double check that by plugging in the 6. We're going to say if k is equal to 6, we'll have 6 times the quantity of 6 minus 5 is greater than 0. And you'll see there that 6 times 1 is 6, and that makes a true statement as well. So we can go ahead here and say that everything greater than 5 is also a solution to this inequality. So to write our solution set, we know that k is going to be less than 0, or k is going to be greater than 5. Now, I'm going to show you in class a couple other ways here that you can check and even solve these. But for right now, like I said, I'd like you to just take it here, identify the boundary points, and then take values to check to see where the solution sets are. Let's move on to another one. Okay, with this one looks a little strange, I know. G squared is less than 0. We're going to take it and we're going to do the exact same thing on this. We're going to say G squared equals 0. Now, if we were going to solve this, we would just go ahead here and take the square root of each side. And in most cases, we would say the square root of g squared would be the absolute value of g, but since this is going to be the square root of 0 is just 0, it's not going to matter if it's positive or negative. With this one, we only get one boundary point, and that is at 0. So we'll put this one on here. I'm going to go ahead and just list some other values. Let's say -1 and a +1. And then this one here, right, is going to be an open circle. So 0 is not really a solution. And let's see if we have any solutions on either side. Let's take it here. And I probably should have used a different color there. Let's say 1 and -1. These are the values we want to plug in. So we've got, if g is -1, when we plug in -1 and square it, we get 1, but 1 is not less than 0. So that does not work. And when we plug in +1 now, we'll end up with the same exact statement there. So therefore, that doesn't work. So there doesn't seem to be anything that's going to make this one true. So in this case here, what we're going to end up with here is just no solutions. This is kind of like one of those special case ones there. Now, I'll show you in class. If you have a question about this, please mark it down there because I'd like to show you why that's no solution from another standpoint in class. All right, I don't know that I'm going to do every problem here, but we'll do this one and then maybe one or two other ones here. Let's see. At any point, if you want to just go ahead and pause it, work through it, and then check to see if you got the right answer, please do so. With the third one here, let's just take it, do the same thing we've already done. Set it equal to 0 first. Then we will factor this one. So we'll have r times the quantity of r minus 2 equals 0. So our boundary points are going to be 0 and 2. We'll list those up here, 0 and 2. Plot them on our number line. Make sure you put the lesser value on the left, the greater value on the right. Since this one is greater than or equal to, we'll put a closed circle. Since when we plug in 0, that will make it true, and 2 will also make the statement true. And then we're just going to choose values again. We'll say 1, maybe -1, and 3. When r equals -1, I'm going to say -1 squared minus 2 times -1 should be greater than or equal to 0. Well, we get 1 plus 2. That gives us 3, which makes that a true statement. 3 is greater than or equal to 0, which means if that is going to work, then chances are our 3 is also going to work. Let's go ahead here and try that one. So if r is equal to 3, we're going to say here 3 squared minus 2 times 3 should be greater than or equal to 0. So we have 9 minus 6 is greater than or equal to 0. And you see there that that makes a true statement as well. Now, I'm not even really going to try the middle one here because I already know that this is a disjunction. So because it's a disjunction there, our solution set is going to be r is less than or equal to 0, or r is greater than or equal to 2. All right, let's move on. Let's jump over this one here. Let's maybe do number 5 here. So 14 is less than or equal to p times the quantity of p plus 5. Let's do this here like it's an equation again. So, whoops, my bad. Let's go ahead there and change that to an equation now. 14 equals p times the quantity of p plus 5. And if we're going to solve this here, we got to simplify each side first. So this is going to be p squared plus 5p equals 14. And since it's quadratic, let's get it equal to 0. This one should factor. It'll factor into p plus 7 and a p minus 2. And then we're just going to use the zero product property again. So p is equal to -7 and p is equal to 2. We'll list our boundary points. We'll put them on our number line. And then remember, since this one is less than or equal to, those are closed circles. Choose your values to find your solution set. I'm going to use 0, -8, and say 3. Any chance I can get to use 0, I usually try to use it there. So let's see here. We're going to do P is equal to -8. When we plug it in here, 14 is less than or equal to -8 times the quantity of -8 plus 5. So -8 times -3 is 24, which makes that a true statement. So looking like it's going to be a disjunction. I feel like everything's been a disjunction so far. That's kind of strange. Maybe because I skipped that last problem here. But chances are here, our 3 should then work as well. Oh, wait, what did I do there? I didn't want -8s in there. I want 3s in there. So we'll switch that up there. Hopefully you're paying attention to what you're doing, because I wasn't. So we've got 3 times the quantity of 3 plus 5, which is 8 times 3 is 24 also. So that one actually checks out. So our solution set for this one should be P is less than or equal to -7, or P is greater than or equal to 2. All right, one more here, just, for practice. Let's look at F. Z squared plus 20 is less than 8z plus 5. We'll take it, set it equal to itself here first, so we can solve it as an equation. Since we have z squareds and z's, I'm going to get everything on the same side. I have a z squared minus 8z. When I subtract 5 from each side, I should have a plus 15 equals 0. So we'll have a z minus 5 and a z minus 3 when it factors. And the zero product property will then tell us that z equals 5 is a boundary point, and z equals 3 is a boundary point. So let's plot those on our number line. With this one, they're open circles. And then choose your values again. So when we do this one here, if we say z is equal to 2, we'll put in there 2 squared plus 20 is less than 8 times 2 plus 5. That'll be a 24 is less than 21, which is not true. So if it's not true, let's just go ahead and jump to the middle one here then. Let's say z is equal to 4. And we have 4 squared plus 20 is less than 8 times 4 plus 5. And that looks like 36 is less than 37, which is a true statement. So finally, we found ourselves a little conjunction here, right? Our answers are going to be everything between the boundary points, which means we can write that as a conjunction up here. We're going to say x is greater than 3 and x is less than 5. That is our solution set. All right, so if you have questions about these, please make sure you mark them down. We'll talk about them in class. I will show you some other cool things that you can do to check these or to even solve them pretty quickly when you're in class here. I just don't want this video to be too long. So thanks for watching, thanks for putting the effort in here, and I will see you in class.